classification. And basically, there are three in number. I'm going to write them on the board. We have the mean, the median, and then the last one is mode. Alright, now, so what is mean? By definition, mean is the arithmetic average. Alright, arithmetic average. Alright, arithmetic average. While the median is usually the middle observation in a distribution. Alright, so this is like the middle observation in a distribution. Then mode is the most occurring data or number. You can use number, right, in a given distribution. So let me run through them again. What is mean? Mean is just the arithmetic average, all right? Then median is the middle observation. Then mode is the most occurring number in a given distribution. Now, our emphasis is going to be on the calculations for the measures of central tendency. Now, for the calculation, we have two ways of calculating this. The first one is ungrouped. Calculation for ungrouped data. Then the second one is calculation for grouped data. What do I mean by that? Ungrouped means the numbers are not in any table or they are not categorized. Are we together? While for group data, the data are categorized in some form of manner. Now, so for this first lesson that we'll be looking at strictly on group data. So on group data, we'll look at calculation for mean, for median, and then for mode. Are we together? So let's start looking at that. So we'll be looking at strictly calculation for ungrouped data. So calculation for ungrouped data. All right. So let's have an example, right? Let's say we want to look at the blood pressure, the systolic blood pressure of, let's say, 8 students in a class. Systolic blood pressure of 8 students in a class. So this is given below, systolic blood pressure. So let's say for the first student, we have 120. The second student is 100. The third student is 110. The fourth student is 112. The fifth one is 122. And then 130. Then 126. And then 110. 1, 2, 3, 4, 5, 6, 7, 8. All right. So this observation, okay, let's make this one 122 still. Let's make this one 122. All right. So let's look at the mean. We want to calculate the mean of this distribution. Okay. So the formula we are going to use for mean, all right. Basically, this symbol X with a bar on top stand for mean. So subsequently, I won't be writing mean again. I'll just write this to symbolize our mean. It's equals to summation. This symbol stands for summation, or you can call it sigma. Summation X all over N. That is the formula for ungrouped data. Please remember, we're looking at ungrouped data because when we get to group data, we also have formula for mean. Alright? Now, so what does it mean? This X symbolizes all these numbers. So this is like X1, X2, X3, X4, and the rest of them to infinity. So even if I just write X1 here, it means I'm adding all the values together. So mean is equals to summation means I'm adding everything together, right? So I have 120 plus 100 plus 110 plus 112 plus 122 plus 130 plus 122 plus 110. Everything, remember, n stands for the total number of observation there, which is 8. Alright, so when you sum everything, you sum everything and then your answer will be over 8. So you sum 120 plus 100 will give you 220 plus this will give you 330 plus this, okay? Say it out. Say, what's the answer?
926.
Okay, so 926. Alright, so 926 divided by 8 will give us 926 divided by 8 will give us 115.75. Now remember, we are talking about systolic blood pressure, and in blood pressure, usually blood pressure is a discrete data. Discrete data means data that are whole number. We can say whole number data. So that means we need to approximate this, right? So it will be approximately 115 mmHg. Alright, so that is the mean. That is like the average. If you bring all these 8 students together, the average of their systolic blood pressure now is 115 mmHg. Remember, please always put the unit because it's very, very, very important. Now that's that about the mean. As I said, it's not something